Hey kiddos, today we're going to be talking about angle of elevation and depression. So, what is an angle of elevation? It is an angle between a horizontal line and a line of sight where the angle is above the horizontal line. An angle of depression is an angle between a horizontal line and a line of sight where the angle is below the horizontal line. Okay? Couple things to notice. The two horizontal lines that you see here are parallel to each other, and the angle of elevation and the angle of depression are congruent. Angles that do this, parallel lines cut by transversal here, this would be called alternate interior angles. Okay? So notice if we were to actually draw a vertical line here, or even here, notice what you're creating or forming would be a right triangle. All right, so first example here, we're going to describe each angle as it relates to the situation that's shown. So we're going to decide whether it is an angle of elevation or an angle of depression. So remember, angle of elevation, okay, kind of way to think about it is it's going up, whereas an angle of depression is going down. So the first angle. So looking at this angle here, notice I see that this is my horizontal line and the location of the angle is below that horizontal line, which then would deem that as an angle of depression. I don't need depression. All right, so angle 2 now. Let's look at angle 2. So I see angle 2 is here. This is its horizontal line, and I notice that angle 2 is located, seems to be above that horizontal line. So angle 2, where this guy's looking, is going to be an angle of elevation. Angle 3, so let's say the guy now changes his viewpoint. Notice here's our horizontal line, and angle 3 is actually located below that angle, or I should say below the horizontal line. So angle 3 is located below this horizontal line. So it's like he's looking downwards now. So angle 3 is an angle of depression. Sounds so sad saying that word. And finally, 4. So if I'm looking at angle 4 here, which is down here, I notice that here's my horizontal line, and the angle is located above that horizontal line, so therefore it has to be an angle of elevation. All right, so next examples. We're going to be labeling each diagram, and then we're going to complete each word problem. If we have to round, we're going to round to the 10th place. All right, so first one. A palm tree casts a shadow of 18 feet long. So notice here's the beautiful palm tree. There's its shadow, so that is 18 feet long. And the angle of elevation of the sun is 25.7 degrees. So here's our angle of elevation. Find the height of our palm tree. So that is where I put X. Now, as you can see, I have already also noticed, because I'm going to have to use trig, because I'm only given one side and I have to find another side. So I can't use Pythagorean theorem. So I went ahead and noticed, based on the angle they've given me, which is here, 25.7, I've listed my opposite side, listed my hypotenuse, and also my adjacent side. So the question is, what we're looking for is, we got opposite, and we know what the adjacent is. So opposite over adjacent means that we're going to be using, that's right, tangent. So we're looking for tangent of 25.7 degrees, which is going to be equal to opposite X over adjacent 18. All right, so now we're solving. So basically all we have to do here is think about cross multiplying here in a sense. So we're going to multiply really 18 times tangent of 25.7. That's going to be equal to our x. Remember, when we're doing this in our calculator, you want to make sure that you are in degree mode first. So when I multiply tangent of 25.7 degrees times 18, I get an answer of x equals, rounding to the 10th, 8.7 feet would be the height of our palm tree. All right, next one. A sign on a roadway at the bottom of a mountain road indicates that the road will incline 10.5 degrees with the ground. Okay, as you can see, they've actually already labeled it for us. Sorry. The altitude for a car ascending up the mountain road is 3,850 feet. Find the length of the mountain road in miles. So the altitude, so we got to figure out where our altitude is and then determine what the length of the mountain road is going to be in miles. All right, so what we have here, this right here is going to be the altitude, okay? So basically going to be 3,850, okay, feet. And we already know that the angle here of elevation is given to us as 10.5. And we're trying to figure out the length of the mountain road. Well, here's the road, so that would be the hypotenuse is what we're looking for. So there's my x. Notice, based on the location of the angle, I've listed the opposite side, the adjacent side, and my hypotenuse. So what we're given is the opposite, and we're also not given anything else, but we are looking for the hypotenuse. So if we're doing opposite over hypotenuse, that means we're looking for, or we're going to be using, I should say, sine. So sine of 10.5 degrees is equal to opposite 3,850 over x, because that's what we don't know. Remember, if what we're looking for is in the bottom, is in the numerator, really we're just going to switch the places of these two. So really when we rewrite our problem, it's really 3,850 divided by sine of 10.5 degrees. And when we work that out, so the answer is that the length of the mountain road in miles is what they want. Oh, they threw a curveball at us. Say miles. My answer right now is in feet. I got 21,126.5 feet, which now we need to convert into miles because, yay, they wanted in miles. So we should hopefully know, or Google, or whatever, that there is 5,280 feet in 1 mile. So we're going to take our answer that isn't currently in feet, and we're going to divide this by the 5,280, and we'll end up with 4 miles is the length of the mountain road. All right, so this next problem we have here, the sonar of a Navy cruiser detects a submarine that is 4,000 feet from the cruiser. The angle between the water line and the submarine is 34 degrees. So the question is, how deep is the submarine? So as you can see, I've already kind of labeled out what the right triangle would look like. So based on this information, this is the hypotenuse. This would be the opposite. So if I have opposite and hypotenuse, that means I'm using sine. So sine of 34 degrees is equal to opposite over hypotenuse. So all we really have to do here is multiply 4,000 times the sine of 34, and we get a grand total of x equals, so the submarine is 2,236.8 feet deep. Next problem, a 20-foot ladder. So the ladder is 20 feet, okay, leans against the house, and the base of the ladder is 5 feet from the base of the house. So base of the ladder, base of the house, that's 5 feet. What is the angle formed by the ladder and the ground? So they're asking for what is this. So remember, whenever we're looking for an angle, we're going to be setting up an inverse, or we're going to be using the inverse function. So first, based on the angle that we're looking for, which is the angle formed by the ladder and the ground, so I've already identified it, we know there would be my right angle. So this is the hypotenuse, and this is the adjacent side. So if I have adjacent hypotenuse, that means I'm using, so cosine of theta equals adjacent over hypotenuse. Now remember, because we're looking for an angle, we're going to be looking for the inverse. So the inverse of cosine is equal to, all right, so when we plug this into our calculator, we get, don't need the equal sign there. Sorry, that's what it would look like when we put it into our calculator. My bad. And our answer is, we're going to round to the 10th, 75.5 degrees. All right, so next one. From a point on the ground, 500 feet from the base of the building, so here's the point on the ground to the base of the building is 500 feet. It is observed that the angle of elevation to the top of the building is 24 degrees. So from here to here, top of the building is 24 degrees. And the angle of elevation to the top of the flagpole, so this whole angle is going to be 27 degrees. Find the height of the actual flagpole. So what you have to do here is you basically have to do two problems. We have to figure out basically what's the height of H, which you can see that's the height of the building. And then we need to figure out what's the height of K, which is the building and the flagpole. And then once we know those two values, we'll just subtract the whole thing, K minus H, and that'll just give us the height of the actual flagpole. So, first thing, let's find the height of the building. So, based on, and this means we're using the 24 degrees here because that refers to the height of the building. That's the angle of elevation there. So, we are given opposite and adjacent. So that means we are using tangent. So tangent of 24 degrees is equal to opposite over adjacent. So to get x, all we have to do is multiply tangent of 24 times 500, and we get x to be 222.6 feet tall. Right? Now, let's switch gears and now let's actually look for the whole thing. So now we're going to this one here. Notice that's still the opposite side. The only difference now is instead of using the 24 degrees, we're actually using the 27. So I'm still going to be using tangent, but it's tangent now of 27 degrees equals x over 500. And when we do tangent of 27 times 500, we get x to be 254.8. So like I said, now we subtract the entire height, which is the 254.8 minus the 222.6. And when we do that, we get the flagpole. So the height of the flagpole is what we're looking for, to be 32.2 feet tall. Next problem. Oh, yo. You guys are going to do this. Now, you got a 2-meter television camera at ground level. And it's filming the liftoff of a space shuttle at a point of 750 meters away. The camera's angle of elevation to the shuttle is 32 degrees at a specific time. Find the height of the shuttle. Now, you do have to keep one little factor in mind. The shuttle obviously started at 0 feet, whereas our television camera is starting meters above. Sorry, because this is meters. And this camera is 2 meters off the ground. So that means once you finish working out and you get the final answer here, you're going to have to subtract 2 meters from it because of this distance here. All right? All right, so now you're given a word problem and you actually have to draw the picture, and we're going to round to the 10th one we're solving here. So here I have a skateboard ramp at a park, and it has an inclination, so that's an angle of elevation, of 54 degrees. As you can see, I've already drawn it. And its base is 12 feet long. The question is, how long is this ramp? All right, well, based on the information I'm given, there's my right angle, so this is the hypotenuse. This is the adjacent side. So adjacent and hypotenuse means I'm using cosine. So cosine of 54 equals adjacent over hypotenuse. Now remember, whenever the value that we're looking for is in the numerator, we really just switch these two locations. So really, what we're looking for, the value, x is going to be equal to 12 divided by the cosine of 54 degrees. So when we do 12 divided by cosine of 54 degrees, we get that this fabulous ramp is 20.4 feet long. B, this is you, 200 yards from a river. Rather than walking directly to the river, the 200 yards, you decide to walk 400 yards along a straight path to the river's edge. What is the angle between this path and the river's edge? So remember, we're looking for an angle. Ding, ding, ding. Gotta use inverse. So let's see what we got. That's where my 90 degree would be. So I got a hypotenuse. And, oh man, looky here. And we got adjacent. So, dun, 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 that means we're using cosine. But remember, looking for an angle, so it's the inverse function of cosine. And that would be adjacent over hypotenuse, 200 over 400. Handy dandy calculator now is going to do the rest of my work. So inverse cosine of 200 divided by 400 tells us that this degree measure is 60 degrees. Now this next one, you already know. Oh, yo.